Okay then guys, just thought I'd run you through briefly the examination paper before we have a look at the questions in this section. This is the May 2011 paper for C2 EdExcel, and it's 1 hour 30 long. Here we put our normal information in for the examination. We've complete the box at the top, centre number, surname, signature, candidate number and such like things. So that's to be completed before we start the examination. Get a mathematical formula booklet here, and we can use a calculator, but it cannot be an algebraic calculator when we can symbolically manipulate expressions to do differentiation or integration or have any formula stored on them, so we need to clear out any memory that we write. So the instructions to candidates then. So complete the box at the top, answer all questions, write clearly and put it in the space following the question. When we use a calculator, use an appropriate degree of accuracy. So that's common sense things, isn't it? We've got our formula book. We need to answer all questions, it says there. Marks are on the right hand side to indicate how long the question should take really, and the corresponding level of difficulty. 9 questions in this paper, 75 marks, 32 pages. So let's have a look at the paper, the question by question then, to see if it's worth doing in any order other than sequential. So here's the first question then. So find the remainder. So this is the remainder theorem. Factor theorem's also here. So we may have to do a bit of division. This is a cubic. So the remainder theorem, this would be easy. Factor theorem is long division of polynomials if we can't find other factors when we have to factorize it completely. This is easy here. F minus 1 is 0, and we just put F1 in and we get the remainder here as well. So the first two parts are easy. The second may require, as I say, long division of polynomials. So let's look at the next question then. So we put our workings in here for the first question. Now question 2. First 3 terms, binomial expansion. So that should be easy, simplify. One coefficient is twice another, find the value b. Fairly easy stuff there for 2. Binomial expansion question. Plenty of room to put our workings as is usually the custom, usually the way. Here, take logs, logarithm question, unwrap a log here. 3 sig figs is where we need to work here in our final answer. So logarithms, very easy, straightforward question there. So let's move on to the next one now. 4. Circle. Coordinates of the center, very easy to write down this equation in standard form and then obtain the radius and find out where c crosses the y-axis. That would be when x is 0, and we find out the answers, giving it the answer in third form. So again, that's a user-friendly question, so there's no surprises here really, are there? So let's move on to the next, flick on to the next question then. I think there's 9 questions in total. Now this question here, rather an interesting question, looks a very awkward shape. We've got a pendant, we've got OAB sector of a circle. This circle here is a radius of radius r, so we're told that. So this is radius r in the information. And there, in one of the parts of the question, we're going to be able to draw these radii in because we need to find the radius in one of the parts down here. I'll just show you the question itself. Find the area of the sector OAB, which is easy, and the radius. Now, the radius of the question, as I say, is not easy to do here, or doesn't appear to be. This distance is 6, and the radius is r, so you've got a triangle in here. See it from the center to O, and that length there is 6 minus r. This radius is r. This line's tangential, so the angle is 90, so we've got a 90-degree triangle on both sides by symmetry. We know the included angle will be half of 60, which is 30. This distance to the center, because this is r, and the total distance is 6, this distance is 6 minus r, and this distance is r. So the sine of this angle is opposite over hypotenuse, because there's a right angle here. So we can get a simple equation in r to solve. But there's other ways to do this question which are a lot more involved, but that's the easy way. So I wanted to highlight that right at the outset before the question is gone through. So that, I would say, is one of the slightly less trivial, finding the radius here, because you've got to be quite observant. Finding the difference in the areas, again, Once you know the radius, it's a very easy thing to do. Okay, so that's that question, which I think is a little bit slightly awkward in that particular part that I took a bit of time to talk about. So let's move on to the next one now. Geometric series, geometric progression, 192, second and third terms. Find the first term common ratio, sum to infinity. And this one here, you can use the formula and try and solve the formula. I would do it by inspection, so once I get a value for n, sum the first n terms, and then by trial and by inspection, so by trial and error, just put in different values for the sum to see when the first one exceeds 1,000. It's quite easy to do. So that's the method I employ in the solutions. So let's move on to the next one, which is number 7 now. Here we go. Trig question. Solving this trig equation is easy, quadratic, and then solving in trig, and show your working. So again, that's very user-friendly. Doesn't look like there's any major problems in that question. So that's 7. So let's click down to 8, the penultimate question. They give us an inordinate amount of paper here to do the solutions, don't they? So here's 8. Here's a figure, rectangular box, 2x by x, called a cuboid. They've mentioned it there. Show that the total length of the 12 edges is this. So the volume is 81. Use the volume, and we'll be able to write the total length. Okay, so that's straightforward. Minimum, and justify that it is a minimum by further differentiation. So again, not a problem, fairly straightforward, user-friendly question. So the last question now, let's have a quick look at this one before we start the exam proper then. Here we are, area of a curve, area between a curve and a straight line, highlighted here. Find the coordinates a and b when the quadratic equals the linear function, and then work out the area using calculus. So that looks like the end of the paper there, because there's 9 questions in this paper. I'm just scrolling down to the end to check. So again, the paper in this particular year, this time looks fairly user-friendly. I see no reason, strong reason to do it in any other way than sequential, because all the questions are relatively the same. But if there is an awkward question that you find more difficult than others, then perhaps you might want to waylay on that one. But when you go through the paper, the good idea is to tick off each one you've done with a little tick, and then if you get time at the end of the exam, if you finish early, double check and put a double tick, of course. And then if you've double checked all the questions, don't leave early. Use up every possible minute and triple check if you get time. So just a quick look at the paper then, guys, just before we start it, just to get an overview of the paper. As I say, there's no surprises really other than that one with the radii in the question. There's no real surprises in this paper. So all the best then, guys, and I'll catch you again in another revision session. Cheers!